Hello student, my name is Nimish Prabhakar. I am Assistant Professor at LJ Institute of Engineering and Technology in Instrumentation and Control Department. Welcome to Process, Dynamic and Control lecture series.
Today we are going to discuss about liquid to liquid heat exchanger and remaining control scheme. In my previous lecture, we discussed about a few control scheme, and in this lecture, first we study remaining of that control scheme and liquid to liquid heat exchanger control. So let's start with the control scheme. So first one control scheme name is the feedback control. Here we study three main control scheme: feedback control, cascade control and feedforward control. Now to understand this feedback control, here we take this is a cell and tube type heat exchanger as an example. So first of all we divide and this heat exchanger for controlling the temperature of the outlet temperature. So here control variable is process fluid temperature. That means this outlet temperature of this process fluid. This is the fluid enter, that means the water enter from this side, and this is the outlet of this water. So here main aim is to control the temperature of this outlet fluid. So for that purpose the control variable is process fluid temperature. Now here manipulator variable is steam flow. For these three control scheme like feedback, feedforward and cascade control, we consider this is a steam flow, this is a manipulator variable. That means by varying this steam flow we control the temperature of the outlet fluid. So for that purpose this is a manipulator variable is a steam flow. And disturbance, the measure mainly there are a number of disturbance that create the variation of the outlet temperature. So but here we discuss about the major disturbance. So first major disturbance is the change in process fluid flow rate. That means this process fluid, this inlet fluid flow rate is changed. This is a first disturbance. Because of this there is a change in the outlet temperature. So that means this we cannot get desired value of the outlet temperature because of the change in the process fluid flow rate. Now second one is the disturbance is change in process fluid input temperature. That means this input temperature, this fluid enter and enter fluid temperature is also another disturbance because that temperature is also varying. So because of this variation the outlet temperature is varying. So this is the second one disturbance. And the third one disturbance is the change in steam pressure, and nothing but the because of the pressure is changed because of the change in the steam flow rate. So the pressure is the third one disturbance. So these are the disturbance, and because of this disturbance we cannot get the desired output, or in other words we cannot get the we cannot get the temperature that we want at the outlet water. So here we control the outlet temperature. So now we start feedback control scheme. So as name suggests, feedback, that means we give the outlet to the inlet. So here the feedback control scheme, we use one controller at the outlet flow and that controller maintain the steam flow, inlet steam flow. That means here our aim is to control the outlet temperature, and for that here we use one valve. So this valve is control the inlet steam. Okay, so same as we discussed in the throttle control, this is in other than them, this is a feedback control. So for this we use here controller that control the steam flow by opening and closing of this valve and regulate the temperature of the outlet flow. So see this, here the temperature controller change steam flow for making output temperature constant. Feedback control require very little knowledge of process. This is a very simple controller, and regardless of disturbance, the controller will take corrective action. But here the disadvantage of feedback controller is like disturbance will first affect process, then it will take action. That means here we take action but after coming of this disturbance. So this is a disadvantage of feedback controller. That means first disturbance occur, then to minimize this disturbance or to reduce this deviation we use controller and we reduce these disturbances or eliminate this disturbance. So that means first disturbance come, then we minimize that disturbance. So this is a disadvantage of this type of control. Now we see second one, cascade control. See, this is a representation or the figure of the cascade control. Now, as name suggests or by definition, cascade loop consists of two controllers in series. That means in a feedback controller we use only one controller, but here we use two controllers in series. Now one is called master controller and second one is called slave controller. The master detects the process temperature and the slave detects a variable that may offset the process temperature. That means here when we use the master controller that detects the process temperature, that means main aim is controlled by the master process, and there are number of variables or a number of reason due to the temperature is vary. So slave controller control that variable. Like in this case, a sudden here master controller is temperature controller and slave controller is inlet flow controller, because here a sudden change in steam pressure will cause steam flow rate to increase. This will cause gradually change in fluid output temperature. That means now we understand here we use two controller. See, this is a steam in and this is a steam out, and this is a fluid in and this represents the fluid out. Now our aim is to control this outlet fluid temperature. So for that we use two controllers. First one is the here temperature controller and second one is the flow controller. This is an inlet flow controller. This is a master controller and this is a slave controller. So here why we need to use this second one controller? Because of some flow changes, that temperature is also changed. So we use for more accuracy two controllers. Like one is the temperature controller and other is also the flow controller. So the function of this controller is to maintain the temperature of the outlet process. So here temperature is controlled by this temperature controller, and this also control the inlet flow of the steam by using this flow controller. So see here, the flow is measured by this, and this transmits the flow to the controller, and this valve used to regulate the flow of the steam. And here the main aim is the temperature control. So outlet temperature is sensed by this device and sent to the here temperature controller, and temperature controller match the output temperature with the set point, and according to that this give controlling action to the flow controller, and the flow controller also maintain the flow of this steam. So this is the cascade connection of the heat exchanger to control the outlet temperature of the fluid. See further about the cascade control. By cascade control, flow loop will quickly adjust valve position when steam flow rate has changed to bring flow back to previous steady state valve value, and thus prevention change in fluid output temperature. Now third one type is the feed forward control. Now here we use controller at input side, that means in the steam flow side, and also we used in the input of the fluid side. So as name suggests, feed forward control. Feed forward control acts beforehand in an anticipatory manner, while feedback control acts in compensatory manner after disturbance has affected the system. That means here this is the advantage of feedback control, that means it acts as an anticipatory manner, while the feedback controller acts as a compensatory manner. So this is the advantage of feedback control system. And here control system consists of two main segments. The feed forward portion of the loop detects the major load variable like the flow and temperature entering process fluid, and calculate the required steam flow as function of this variable. That means here see in the figure, this represents the steam in, this represents steam out, and this represents fluid in, and this is a fluid out. What is the aim? Aim is to maintain the temperature of the outlet temperature. So for that purpose here we use the two controller. First one is the temperature controller and second one is the flow controller. See here in input side, here we use first we measure the temperature of inlet water, that means inlet fluid temperature is measured by this device, and also the control of this temperature is by using this device. Then list the inlet water temperature and inlet water flow, both measure first and give to the temperature, and according to that inlet water and flow also here we measure the temperature and the flow of this steam, inlet steam flow. So to maintain this outlet temperature we control the flow control of the steam. So this is a simple arrangement of the feed-forward controller. Here we use the controller at the input side. That means we use controller to control the temperature of the outlet temperature. So this is a simple feed-forward controller. Now liquid to liquid heat exchanger control. See, this is a second one type of the heat exchanger. It also known as a tube-in-tube heat exchanger. That means here one liquid exchange energy with the other liquid. Here one liquid is flow in this tube and second one liquid flow surrounding this tube also. So this is called tube in tube. This is a one big tube. In that tube we place second one tube. So this is known as tube in tube. So this is the inlet of the fluid 2 and this is the outlet of the fluid 2, and this is the inlet of the fluid 1 and this is the outlet of the fluid 2. So in this heat exchanger, hot fluid enter from this side and hot fluid out from this side. Cold fluid enter from this side and cold fluid out from this side. So this is a simple liquid to liquid heat exchanger. Also this is only one tube. Here we use a number of more tube. So the function of the working is the same, but here we increase the number of tube. So this is a multiple tube heat exchanger. Okay. Now we understand the energy balance equation. So in liquid to liquid heat exchanger, energy balance equation is written as FH into CPH TH1 minus TH2 is equals to FC CPC TC2 minus TC1. So here first one term is represent heat given by hot fluid. That means hot fluid that give heat to the cold fluid. And second one term, that here this side, this represent the heat taken by the cold fluid. So this is a second one term represent. See, this is a symbolic represent of the heat exchanger. Here the heat, this is the hot fluid come from this side to this side and the cold fluid flow from this side to this side. This is a temperature of the hot fluid inlet and outlet, and we use one valve to control the temperature of the outlet fluid. So we place this valve. Here in this equation, CPH and CPC, these two terms is represent, the CPH is represent the specific heat of the hot fluid and the CPC is represent the specific heat of the cold fluid, and same as TH1 and TH2 is represent the inlet and outlet temperature of the hot fluid, and TC1 and TC2 is represent the inlet and outlet temperature of the cold fluid. And here FH and FC is represent the flow of hot water and flow of cold water. That means cold fluid or hot fluid. Now the dead time of a heat exchanger equal is volume divided by the flow rate. So we can represent in mathematical term dead time is equals to volume by flow rate. Now as process flow increase, the dead time is decreased because these two terms are inversely proportional, process flow and dead time. Now we can write the dH2 by dFc from this equation as, that means we differentiate the TH2 with respect to Fc. So we get this term from this equation. So by solving this equation we get the steady state gain is dH2 by dFc is equals to CPC upon FH into CPH. So this term is represent the steady state gain. If in this equation CPH and CPC is equal, that means value of CPC and CPH is same, so at that time the steady state gain is equals to 1 upon FH. Now in this condition, as the process flow decrease, that means FH is decreased, the process fluid will spend more time in exchanger. Also load is reduced, the exchanger become relatively oversized and therefore it become a faster and more effective heat transfer device. And second one case in this, as process flow increase, FH is increased, the exchanger become less and less effective. So this is a liquid to liquid heat exchanger. Okay.